In this example, we wish to list the zeros of the equation y equals x times 2x minus 7 times x plus 5. First of all, what do we mean by zeros? Zeros of a function are the x values that make the function value 0. So to find the zeros, we want the y value, which represents the function value, to be 0. So it is now our job to solve this equation. We need to find all of the possible x values that will make this statement true. So what x values can we plug in on the right-hand side that will make the entire right-hand side go to 0? Thankfully, this function is written in a factored format where we can clearly see our three factors. And we can bring in the 0 factor, or some people say 0 product property, which says if I have two real numbers a, b, and I multiply them to get 0, and again, if a and b are real numbers, then the only way I can get this to happen is either a is equal to 0 or b is equal to 0. That's the only way I can take two real numbers, multiply them together, and have a result of 0. So going back to our function here, again, it's very nice that this is in factored form. I just need to know when would each of my factors be equal to 0. Starting with the first factor of x, there's really not much to do there. If x is 0, that would make the entire right-hand side be 0. So that is one of my zeros of my equation. The second factor, 2x minus 7, I want to know when would that be equal to 0. So this one does create a little equation that I can solve. So I'm going to add 7 to both sides and then divide by 2. So positive 7 halves is another 0 of my equation. Our third factor, x plus 5, when would that be 0? Well, x would have to be negative 5. If we subtract 5 from both sides, we see that our 0 would be negative 5. So the zeros are 0, positive 7 halves, and negative 5. And you could have these listed in any order. They do not need to be in increasing or decreasing order. We're not describing an interval here. These are just independent values, so it's like a grocery list. You can list them in whatever order you wish.